Hey everyone, this video focuses on some more advanced topics when it comes to programming in Proficy Machine Edition. We're using version 9.5 and we're programming Emerson RX3i PACSystem Controllers. In this case, we're using an IEC 695 CPE 305. And the video focuses on user-defined types, or UDTs, as well as user-defined function blocks, or UDFBs. Now, a user-defined data type, or UDT, is a structured data type that consists of a variety of data types, and those can be reals, integers, uints, words, dwords, etc., etc. And so think of a user-defined type as basically a class, and inside that class you have a variety of member variables, and those, again, member variables take on different data types. And after you define a UDT, then you can create a structured variable. So when we say structured variable, I'm not saying like an integer or like a real value variable. It's a structured variable. It's a variable of type UDT, which you would define. And then when you create that structured variable of that specific UDT data type, then you can reuse it in your logic. And then what's really cool is you can create what's called user-defined function blocks, or UDFBs, which can be used in ladder diagram or structured tag or function block that basically has its block type property set to a function block. And the UDFB is then defined with input parameters, which could reference your UDT that you've just created, as well as have output parameters. Maybe you want to have some outputs, and then internal member variables that are local to the function block to do some sort of logic. You could have a user-defined function block that produces some sort of logic and takes an input of a UDT, and then basically it just allows you to model typical logic in your program, which you can reuse. So they're very, very useful, and they help you reuse code. They make your logic very modular. You can result in less code for programming. You're basically doing it once, and then you basically just copy and paste it everywhere in your code. So there's less maintenance required, less project load and validation, load times. And when you modify a single UDFB and you've made those modifications to it, guess what? They then basically take effect into everywhere where you've reused that UDFB. So it's basically instantiation. It's reusability instantiation of your logic. So really incredibly useful. Now, I've said a lot, and we're going to be using UDTs and UDFBs in this video. Specifically, we're going to be doing this through a little exercise. What we're going to be doing is we're going to create a UDT to model just a very simple motor, and we're going to call that UDT motor underscore UDT, just for simplicity. Now, this UDT is going to be defined with three member variables. Since it's a motor, we're going to want to be able to start the motor using a push button, so we'll call a member variable start underscore PB. It's going to be a Boolean variable, either 1 or 0. And as for stopping the motor, well, we're going to need a stop push button to stop the motor, and that's going to be a Boolean variable called stop underscore PB. And then finally, we're going to have a running status to track whenever the motor is running based on if we've started or if we've stopped it. And we're going to call that running underscore status, which will be a Boolean variable. And then, once we created our UDT to model a typical motor, well, we're going to have to create a user-defined function block to handle all the inner logic to control and manipulate that motor. So we're going to call a UDFB called motor, and basically that user-defined function block is going to have the logic internally to start the motor based on our UDT and stop the motor as well, and then maybe count the number of times we've started the motor. And it's going to be using an input parameter, which will be our user-defined type called motor underscore UDT. And in terms of the name of the input parameter, we're just going to call it motor. And then we're going to have, of course, an input on to reset the number of starts for the motor. So every time the motor has turned on and we track it, maybe we want to reset those starts. So we'll have an input parameter called reset underscore starts, just to restart our counts. And then on the output side, we're going to have a parameter used to track the number of times the motor has started. So I know it's a lot to chew on, but we're going to be walking through this together, and we're going to create this UDT and UDFB. So without further ado, let's get started. Now here I am in Proficy Machine Edition, and I have just a very basic program. I have a simple hardware configuration with a power supply, my 305, as well as my network module in slot 4. And then I have a program block, which is a default main ladder diagram block where all the code begins execution. So we are currently offline. We're not actually online in the controller because we're going to want to create our UDT, we're going to want to create our function block, and then basically set up all the logic before we download to the controller. So what I always like to do when we create UDTs and function blocks is we're going to want to be very careful on how we introduce them into our logic. So under our user-defined types, let's go ahead and create that UDT called motor underscore UDT. So I'm going to create a new user-defined type under the user-defined type section, call this motor underscore UDT. And if we just double click it, we'll see we have a blank canvas in terms of our member variables. Now, if you recall, we have 3 member variables: the start push button, stop push button, and the running status. So for the first element, let's call this start underscore PB, which will be a Boolean data type. We have our stop push button, which is also our Boolean data type. And what do we call this? Start motor push button, stop motor push button. And then finally the running status, running underscore status, which will track every time the motor is running. So motor running status. And that is it. There's our very simple motor user-defined type. Now let's go ahead and create the function, the user-defined function block to handle the logic of our motor. So under our logic program blocks, I'm going to create a new folder, and I'm going to call this function underscore blocks. And under here, I'm going to create my new function block, and I'm going to call this, oh, sorry, this is not it. I'm going to create a new ladder diagram block. I'm going to call this, based on what we've talked about, a motor. So I'm going to call this motor. And then in the motor, we can see here, if I just click it selected, it's a simple ladder diagram block. It's not a user-defined function block because we haven't defined any parameters for it yet. So what I'm going to do is I'm going to go to parameters, and then for my input side, if you recall, one of the inputs is of course our motor UDT. So I'm going to call this motor, and the data type is our motor UDT. That's one of the inputs we're accepting, and this is going to be our motor UDT. And then this motor variable as our input parameter is basically what we're going to be using when we start defining the logic internally, and I'll show you that very shortly. And the second parameter, if you recall, is the reset starts command, which will be able to reset, I think it's reset starts command, which is a Boolean input used to reset the ongoing times that motor has started. So reset number of times motor has started. Just increase that there so you can see what I've just typed. And that's it for the inputs. And then also, if you recall, on the output side, we have our start underscore counts. So start underscore counts, which is going to be a integer, basically going to say, the integer is going to keep track of how many times the motor is started. So tracks number of times motor has started. And then finally, we have some member variables. These are internal variables held within the motor. Now, what I'm going to do is I'm going to create an internal variable that all it does is it's going to track the number of it's going to track as a temporary variable. It's going to be a temporary running status variable to track each time the motor has just started. So I'm going to call this temp underscore running status, and I'll just show you that how we're going to use it later on in the program. So temporary, or actually call this, no, I'm going to call this last scan running status, which will track the last scanning status of the running status of the motor, if it's been running or not running. So last scan status of motor running. Okay, and then that is it. So we'll say okay. And now you can see here a few things have changed. We now have a block type of function block, and you can see also the look and feel of the motor has changed beforehand from just a simple LD block to a function block. Now, the really cool thing about function blocks, particularly a user-defined function block, is you can now double-click it, and you'll see here a new tab open. And now this is where we're going to be defining our logic for this particular instantiated motor. So I'm going to go ahead and I'm going to just go to my PLC ladder. I'm going to create a couple things here. I'm going to create a normally open contact, a normal open contact here, a coil here, and a normally closed contact here. And I'm going to group this all together with my wires, creating a branch. And I'll show you what this is happening in a second. So this is going to be our start command. So I'll call this motor dot, and if you recall, we have the start push button. So if you see here motor dot, and you can see it's all in yellow, this just means that this is calling the input start push button, which we've referenced from our user-defined type. But when we define the parameter for the motor function block, if you double click it, we can see here we've called this motor, which takes on the data type UDT. So every time we're passing in our motor UDT, whenever we're using it within the function block, we always refer to it as motor. So if I click OK, we can see here motor dot, and then referring to the start push button number variable of the motor UDT. Similarly, we have the motor dot running status, which would then refer to the coil whenever the motor is running. And then finally, we have the motor dot stop push button. So we can see here basically what will happen is when we pass in the start push button, it will engage a start command for the motor, and the motor will then run because it's going to latch itself in. We no longer need the start push button. And then as for the stop push button, if we've pressed it, then the motor will stop. So very, very, very simple logic. Now the next thing that I want to do is just above this, this is where we have that last running status variable. I want to track the last time the motor has run. So if I go to move bool, what I want to do is, if the motor was previously running, I want to move that, whether or not it's previously running for that reason, I want to move the last known running status into my last scan running status. You can see here, we're not following it with a motor dot, right? Because we're not referencing a user-defined type in terms of our input parameter. This is actually an internal parameter. This is a member variable of our user-defined function block. So because of that, we can see here we don't have the motor dot as a prefix. It's just something internal in the block. So therefore, it's just last scan running status. So what I'm going to do is I'm going to take on the last scan running status based on the last known running status of the motor UDT. And then down here, what I want to do is I want to say if the motor was, let's see here, if the motor is now running, so we're going to go like this. If the motor is now running, and actually, you know what? This is incorrect. We have to move this to the end. This should not be at the beginning because the status has to change based on the very end. So we're going to go something like this. Sorry about that. So if the motor is now running, but the last time we finished scanning this block, this function block, we saw that the motor was not running, meaning it was false. Therefore, at the last scan, when the scan completed, if the motor was not running and now it is running because we've just executed some logic in rung 1, now that the motor is running, we're going to actually execute an add integer command, instruction. And what we're going to do is we're going to add 1, if you recall, to that output parameter called, I think it was called count, what was it called? Now I forget. Parameters, outputs called start counts. So go to start counts, which tracks the number of times a motor is started. So I'm just going to add 1 to itself to track it every time this changes. And if you recall, this is only going to get executed once per scan on the change, because what will happen is, let's suppose that rung 1, motor is running, and the last time the scan took place, it wasn't. So therefore, motor is running, the last scan it wasn't, therefore run this command, add 1 to start underscore counts. Now this is now 1, assuming it was previously 0. And then when this move bool instruction takes place, the motor is now running, so then move a 1 into the last scan. Therefore, the next time this executes for the next scan, we can see here that this won't execute because now the last scanning running status will be equal to the motor running status. So therefore, we will not execute this add integer instruction again until, of course, the motor turns off and then turns on again, and then we'll be able to execute it. Now, the last thing I want to do is have the ability to reset the number of starts based on the input parameter. If I just recall, go to the parameters, because your input was called reset underscore starts. So what I'm going to do is, at the very bottom here, just underneath this add integer, I want to do a move instruction, move int, and I want to move a 0 into our start counts every time that start command is true. So if we go to the beginning of the run, we'll add restart underscore starts. This is that reset starts command, and what I want to do is just link it up so that as long as this input is true, it's going to move a 0 into our start counts. And that's basically it. So let's just recall again our logic. We can see here very, very simply in the first rung, if the start push button is pressed, being passed in as that user-defined type, we will start our motor, and the motor running status will be true, granted the stop push button is not pressed, and then the motor running status just latches itself in, and if you click the stop push button, it will unlatch it and it will stop the motor. We have the transition from stop to running. We'll then increment our start counts by 1. In rung 3, if we have a reset underscore starts command as the input being high or true, we'll just simply restart the count to 0. And then this is on the last scan. And then finally, what I didn't do, but what I want to do is every time we have a start command or a stop command on the push button, I want to reset the status of that variable to 0. Meaning, as soon as the start comes in, assuming it's a push button command, I want to just get rid of it. I want to reset the start command or stop command for that reason to 0. So it's not maintained, it's basically a rising edge. It goes on, and then I want to turn it off. And that's it. So we're done with this user-defined function block. Now let's go back to our main routine, and now we're going to be using our function block. So the first thing I'm going to do is I'm going to click instruction, and if I just type in motor, you're going to see here, typically when you add in an instruction, you have like all these moves or reels or multiplies, all these typical instruction sets. But because we now have a motor function block that we've defined, we can basically just type it into our instruction set, and now we have a function block instance of that motor function block. Now, basically what we'll be able to do now here is we'll be able to pass in our motor UDT under the input parameter that we've defined. So I'm going to call this my underscore motor underscore 1. And this is going to be a instance of a typical motor. And we can see here under variables, we have a data structure for it, which takes on the 3 member variables based on that motor UDT data type. And as we saw, the 3 member variables are running status, start push button, stop push button. Now, if you recall, we also have a reset starts input parameter, which is basically going to tell the motor, do I want to reset the ongoing count for the number of times the motor is started. So we'll call this reset underscore starts underscore command. And I'm going to just wire up the top. And on the output side, this is again tracking the starts. This is the output of the function block. We'll call this motor 1 underscore num starts, something like that. And then because this is finally a parameterized, a function block instance, we've got to create a function block structure for this. We'll call this function block underscore my underscore motor underscore 1 comma g to make this global. And now, under structures, we can see the structure of our user-defined function block, which will show us all the different internal variables, including the member variables, input variables, and there's that motor which input variable which takes on the motor UDT we pass in. So a lot has been said here, but now we should be good to go. What I'm going to do is I'm going to validate my program for any errors. And we just have some warnings, and what's our warning? Oh, okay, it just sent to a retentive value. That's totally fine. So let's connect. And now we're going to connect to our PLC. And now that we're connected, we're going to go into programmer mode. And we're going to download to this PLC our program. So let's do a download. And we're going to say OK. Let it run through. And then let's go ahead and start our controller. So let's go outputs enabled. Okay, so let's do a few things. I'm going to go ahead and I'm going to right-click my user-defined type called my motor 1, which takes on motor UDT, and I'm going to do a data watch on it. I'm going to move my data watch outside so you can see it, and then just expand it. And then I'm going to go into my motor user-defined function block so we can actually see the logic execute. Now we can see here, basically when we pass in our my motor 1, which takes on motor UDT, which we pass in as an internal value of an internal variable name of motor. If I go ahead and write a 1 to my start push button for my motor 1, we can see here that the motor dot running status is now true. It's now running, and we'll notice that it's then the start push button variable has now set itself to off, and that's because the end of the logic has executed, whereupon we just do a reset coil on our start push button so that it's not maintained, it just simply goes off. And now that we're running, we can see our running status internal member variable of our myMotor1 UDT is now on, right? And then if we execute a stop command, basically using the stop push button, we can see that the motor running status is then turned off. Now, if you recall, every time the motor is started, when the motor was not running last, we can see we just simply add 1 into our starts count. So we're basically keeping track of how many times the motor is started. So watch this. If I try to write a 1 to the start push button again, we can see now the count is incremented by 1. And vice versa. If I stop it and then start again, now it's incremented by 1. So it's really, really cool to see that every time the motor has started, the last scan would be false, and then because we've just started a motor, it would be true. Therefore, we've incremented the starts count by 1. Now, let's go outside our function block and take a look at the input side and the output side. There's our outputs. We can see the start underscore counts, which we just saw inside the internal logic of the user-defined function block, is now passed on as an output called motor1 num starts. So we can see that increment by 1 every time the motor is started. So let's stop the motor, and let's start the motor again, and we can see that 3 becomes a 4. Now watch this. If I go ahead and pass in a 1 for our reset starts command, and I just toggle it, now it's equal to 1, we can see we've reset the number of times our motor has started. And if I dive into the function block, we can see at the bottom here, we can see the 1 is being passed in, Boolean high 1, therefore we're moving a 0 into our start counts, which again is an output passed out of the user-defined function block. Now, if I turn this off again and then I try to start our motor, we can see that we're starting back at 0 and then passing in the motor's already running. Let me just stop the motor, and let's start the motor again. We can now see we're passing in a 1 again, beginning from 0, therefore the number of times the motor is started is equal to 1. And let's just stop the motor. Now, as I mentioned before, these are parameterized user-defined function blocks, so they're absolutely reusable in your code. If I really wanted to, I can copy this, paste it just below in rung 2, and I can go ahead and declare another typical motor. Maybe I'm controlling another motor. Let's call this my motor 2. And then I want another reset starts command for this particular motor. So let's call this reset starts command 2. And then of course, we're going to have to declare another function block, my underscore motor underscore 2. And then on the output side, we'll call this motor underscore 2 num starts. And the beauty of using user-defined function blocks is I don't have to now modify the internal logic as to how we're modeling this motor, because it's taking on the internal logic of that user-defined function block. We're basically instantiating it. We're using it again as another typical function block to model my motor 2, just like we modeled my motor 1. So guess what? I can click on my data watch and I can see this motor as a separate instance, and now I can do a start command, and now look, the motor is running. And if I want to do a stop command, the motor is off. And now I can track, of course, my number of starts. So all this to say, user-defined types paired with user-defined function blocks are incredibly useful, and they're used to basically break up your code and allowing for usability, for instantiation. Therefore, your code is more modular, it's easier to use, and if we just modify this user-defined function block, maybe we want to add some more typical logic to it to make it a little bit more complex, maybe add some more features and functionality, we can do that. And as a result, it will just update our function blocks for both of these motors, and therefore we would have increased functionality. Maybe you want to track some faults, or you want to add some more push buttons, maybe in an emergency stop command as an example. So a little advanced, but really useful, and again, just helps break up your code and allows for easier maintenance, easier understanding of your logic. So thank you so much for listening. Thanks for tuning in, and appreciate you hopefully learning something in our Proficy Machine Edition.